Hello everyone! So for today, before we proceed with our lesson on trigonometry, so I just want to share you those light moments, happy moments, or bloopers, unexpected reactions in every episode we make. So I hope you will enjoy watching them, guys. So yalla, let's go!
Okay.
So other example. So each number. So, hi guys. Dun nga tayo. Hello everyone. Rico Leaks once again and welcome back to another episode of MATHFLEX.
Serious.
And okay. So episode 7 we discuss about blah 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 blah. What? Again, for those fellow chemical engineers or chemical engineering, so for all of those chemical engineers, again for all.
NANI?! お前はもう死んでいる。
Using the choices, I think you can immediately or outrightly eliminate two of them. Okay, so you have this first. Now, by just looking our kidney, it's also good for our kidney since it lowers our blood pressure, and also it's also good. And so let's try to solve that in 5 minutes. So join me, guys. Let's go. Timer. Ay, hindi na mga plato. So it's just so awful that this incident happened. It's just so awful that this incident happened in the midst. It's just so Mubarak to all our friends, especially to our Muslim brothers. Okay, so that's it for today's episode. What's up, everyone? What's up, everyone? So September. What's up, everyone? So as mentioned a while ago, our topic for today is trigonometry, and under trigonometry we have this basic SOH CAH TOA. So what is SOH CAH TOA? This is the famous mnemonics used to easily remember trigonometric ratios. Say you have a right triangle here, and you have the base of that right triangle, or base of this right triangle, and you have the altitude and the hypotenuse, and you want to get your reference angle theta. So you can apply your trigonometric ratios using SOH CAH TOA. So means sine theta is equal to opposite. The opposite of this is that over hypotenuse. So if I want to take the sides, so it will be A over C. Okay? And if I want to use another trigonometric ratio, which is cosine theta, it will be adjacent. This is your reference angle. This is the adjacent over hypotenuse. So adjacent over hypotenuse. So if you will take the side, this will be adjacent over hypotenuse, which is B over C. TOA means tangent. So tangent, theta then, is equal now to your opposite over adjacent. Opposite over adjacent, so that is your tangent. Opposite over adjacent, which is equal to A over B in terms of the sides. Now we have another set of functions which are actually the reciprocal of these three main trigonometric functions. So the reciprocal of sine theta is cosecant theta, which is the reciprocal. So if sine is opposite over hypotenuse, your secant now would be your hypotenuse over your opposite, or in terms of the angle, it's C over A. So the reciprocal of cosine is secant, okay? So which is the inverse of this one, which is C over B. And the tangent, its reciprocal is called cotangent, which is equal to B over A. So let's try some examples to illustrate more the function or the use of SOH CAH TOA. So the very first trigonometric identities I've learned when I took trigonometry is tangent is equal to sine over cosine. So problem number 1, we are asked to prove why tangent is equal to sine over cosine using this right triangle. So as we mentioned before, so tangent using SOH CAH TOA, so tangent theta, if this is my reference angle, so it will be equal to the opposite over adjacent. So this is A over B. Similarly for sine theta, using our Sohcahtoa mnemonics, so it will be opposite over hypotenuse, so which is equal to A over C. So subsequently for cosine theta, you will have your base over your hypotenuse, or cosine is adjacent over your hypotenuse. So that means we have B over C. Now, let's try to substitute this with the sides of your right triangle. So we say tangent is equal to A over B. So tangent theta is equal to sine theta over cosine theta. So tangent is A over B. And then if I'll substitute sine theta, which is A over C, and then cosine will be B over C. So you would notice here that C will cancel there. So A over B is equal to your A over B. So that proves that tangent theta is equal to sine over cosine theta. So let's go to the next problem. Our next problem is actually a board exam problem. And it says we have to find the cotangent of theta if the sine theta is equal to 0.6. Now you can solve this one in many ways. You can simply take the value of your theta by taking the inverse sine of 0.6, and then you'll get the cotangent of that theta. That's another solution. But for today, I'll be showing you how to arrive with the cotangent of that theta using our right triangle. So if this is our right triangle, okay, and you have your reference angle there, and then this is a right triangle. So you have your base here, and then you have your altitude and your hypotenuse there. So the problem says sine theta is equal to 0.6. So if I have sine theta is equal to 0.6, so expressing this one in terms of fraction, this is 6 over 10. So reducing 6 over 10 in the lowest form, so that is 3 over 5. So therefore, Sohcahtoa means sine opposite over your hypotenuse. So opposite over your hypotenuse. So this is A over C. So that means your A is 3 and your hypotenuse is 5. So this is 3 and then you have 5. Now we are asked to find the tangent. So cotangent, sorry. So tangent theta is equal to A over B. So the reciprocal of tangent is your cotangent, which is B over A. So therefore, cotangent theta is equal to B over A. So in this case, we don't know what's the value of your B, but you can solve it in many ways since you know the theta. So you can make sine theta to get, or cosine theta to get the value of B, or using Pythagorean Theorem. So in this case, we can get B using Pythagorean Theorem. So by Pythagorean Theorem, so it says like the square of the hypotenuse, C squared is equal to the sum of the square of the bases, so A squared plus B squared. So therefore you have 5 squared is equal to your A squared, which is 3, plus B squared. So therefore B squared is equal to 5 squared minus 3 squared. So B is equal to the square root of, so 5 squared is 25 minus 3 squared is 9, so that is square root of 16. So your B value is equal to 4. So therefore this is 4. So cotangent theta is equal to B over A. So our cotangent theta here should be 4 over 3. So this is our answer for this problem. Okay? So our next problem is somewhat similar to our second problem. So it says sine theta is equal to x. Now we are asked to find the value of cosine theta. So again, using our right triangle. Okay? So we have our reference angle here, and it's 90-degree triangles or right triangle. So we say sine theta is equal to x, or this can be like x over 1. So sine theta is opposite over hypotenuse. So this will be, if this is my theta, so opposite, that is x, and my hypotenuse is 1. But we are asked to find the value of our cosine theta. Cosine is adjacent over hypotenuse, which is adjacent over hypotenuse, or this is equal to your B over C. So we know already C, which is equal to 1, so, but we don't know what's the value of our B. Okay? So again, by Pythagorean Theorem, we can get the value of your B. So C squared is equal to A squared plus B squared. So therefore you have C squared, which is 1, and then you have your A squared, which is X squared, and then you have your B squared, which is, we don't know. Okay, so B squared then is equal to 1 squared minus X squared. So our B then is equal to the square root of 1 minus X squared. So therefore, our cosine theta is equal now to B, which is the square root of 1 minus X squared over 1. Or simply, our cosine theta here is equal to the square root of 1 minus X squared. Okay? Okay, so that's it for today's episode, and we will be solving more problems on trigonometric function or trigonometry on our succeeding episodes. So for the meantime, I hope you like the video, and don't forget to like, subscribe, and click the notification bell for you to get updated on our succeeding videos. Until next time, bye-bye!